All right, here we go. We are back. Okay. This here we're starting with number 14. Let's dial it in. So we're starting with number 14. We have a SOAP problem. All right. When we're factoring, this is a difference of two perfect cubes. Remember SOAP. I'm going to write this down for you. A cubed minus B cubed. Same sign. Opposite sign. Always positive. SO, always positive. So, my A term, the cube root of 8 is 2, the cube root of x is x, the cube root of 27 is 3. Alright? A squared. So I must square. You square the 2 and the x. Don't forget that. A lot of people make that mistake. Make sure you have 4x squared. Alright? Minus a times, or excuse me, plus a times b. So plus 2x times 3, so 6x. And then plus b squared, which is 9. This is all equal to 0. Well, if I were to solve this is a 3, by the way. If I were to solve this, I would get x equals 3 over 2. This here, alright, this trinomial here, I have to use the quadratic formula. I have to use the quadratic formula for this, okay? Because it does not factor. So x equals opposite b plus or minus square root. Wow. B squared minus 4a c. Oh, I see. All over 2a. Wow. You're just like grinding through these videos. Negative 6. Plus or minus. If I do 36 minus 4 times 9, I get negative 1. No buckets. Don't stop. Don't quit on me now. 0. 8. All over 8. Okay. Keep going. Negative 108 is 23 times 3, or excuse me, 23 times 3. Is 36 times 3. How did I get 23? Where does 23 go in it? How do you get 36? 23. So this is going to be 6I root 3, since it's negative 108. All over 8. And I can reduce by 2 to get negative 3 plus or minus 3I root 3 over 4. Hallelujah. There you go. How about that? That's exciting stuff. Let's keep going. Let's keep going. All right. Absolute value. All right. So first off, I'm going to have a positive. Remember, absolute values we have to solve twice because when taking the absolute value of a number, if I take the absolute value of positive 4, I'll get 4. If I take the absolute value of negative 4, I'll get 4 as well. So I have to also consider the negative of my bars. That's supposed to be a parentheses. Alright, the negative. But I'm going to do the positive first, and then I'll come back to the negative. So I have x squared plus 4x equals 3x plus 6. I'm going to move everything to one side so I can factor. Minus the 3x, I'll get plus x minus, subtract the 6 over, equals 0. Alright, two numbers that multiply to negative 6 and add to 1. X plus 3, x minus 2 equals 0. So x equals negative 3 and x equals 2. Well, what's it going to be? Remember, we have to check for extraneous solutions. Alright, well, if I plug negative 3 in here, I get negative 3 times 3, which is negative 9 plus 6, gives me negative 3. If I take the absolute value of a number, I will never have a negative answer. So I can throw out the negative 3. 3 times 2 is 6. 6 plus 6 gives me 12, so 2 works. Okay, let's go over here to the negative portion. So I have negative x squared minus 4x equals 3x plus 6. Now, I don't like factoring with a negative x squared, so I'm going to move everything to the right side of my equal sign. So it'll be 0 equals x squared plus 7x plus 6. So that's x, two numbers that multiply 6 and add to 7, x plus 6, x plus 1 equals 0. So x equals negative 6 and x equals negative 1. Well, if I plug negative 6 in here, I'll get a negative answer, so I can toss out negative 6. If I plug negative 1, it's negative 3 plus 6, which gives me a positive answer. So negative 1 and 2 are my solutions. Boom! We are cruising now. We are flying. Okay. First step when solving a rational equation like this, I want to make sure everything is factored. So this factors x plus 5x minus 4. And then I'm going to multiply the entire problem by the LCD. Okay, my least common denominator. All right, my LCD or is x plus 5 x minus 4. Okay, that would be my common denominator. All right, if I were to solve this out. So remember when we do this, okay, I'm gonna write this step in, and you don't have to include it, but I'm just gonna write this in so you see what happens. So we review what happens. I multiply every single term by this, right? So I have x times x plus 5 and x minus 4 all over x minus 4 minus 4 x plus 5 times x minus 4 x plus 5 equals 36 over x plus 5 x minus 4, and these are coming back, x plus 5 x minus 4, close the door. So we're going to go through, remember, now you could maybe do this part in your head, alright, but I'm just going to show what happens here. The x minus 4's cancel here, the x plus 5's cancel here, both factors cancel in our last term. Alright, so here I just distribute my x through, so I have x squared plus 5x. Alright, and here, remember, this negative goes with the 4. Alright, this negative goes with our 4. So really, if I were to do this, okay, it'd be the same thing. Now here's the deal, a lot of people make this mistake, they forget about this negative and they write it as positive 4, and it's just not going to give you the same thing. So I'm just going to leave it like that, so that I have minus 4x plus 16 equals 36. Alright, so if I combine my like terms and move the 36 to the other side, I get x squared plus x minus 20 equals 0. To get two numbers that multiply to negative 20 and add to 1, x plus 5, x minus 4 equals 0. So x equals negative 5 and x equals 4. Now, we must check for extraneous solutions. Okay, must check for extraneous solutions. So if I plug in negative 5, if I plug negative 5 in right here, I get negative 5 plus 5, which is 0. Can't divide by 0, so negative 5 is out. Some of you may already see it. If I plug in 4, 4 minus 4 gives me 0 as well, so 4 is out. So now, well, that means, how does that turn into that? I have no... Oh my goodness. I can't even write no solution. Okay, so no solution. Alright, 17. Here we go. This looks funky. Well, since it looks funky, I have x to the 2 over 5 and x to the 1 over 5. That tells me if I have something funky like that, I'm going to have to use u substitution. So this is going to become 8u squared minus 10u minus 3 equals 0. Okay. This you could do two ways. All right, I could use the quadratic formula, or I could do split the middle. I'm going to split the middle. 8 times 3 gives me negative 24. So two numbers that add to negative 24. Excuse me, multiply negative 24 and add to negative 10. Well, 6 and 4, well, if I have negative 6 and negative 4, they'll add to negative 10, but they won't multiply negative 24. So you got to be careful. It has to be 12 and 2. It has to be 12 and 2. So I have to have negative 12u plus 2u minus 3 equals 0. Remember 4 terms. Factor by grouping. Alright. GCF here between 8u squared and 12u. I can take out a 4u to give me 2u minus 3. Here, 2u and negative 3, I can just take out a positive 1. And then left over is 2u minus 3. And that's still equal to 0. So, 2u minus 3, we win. We have a repetition. 2u minus 3 is one factor. Take the 2u minus 3 out. What am I left over with? I'm left over with 4u. Not for me, but for you. Plus 1. That was pretty lame, but I liked it. ILL, just a tiny bit. Okay, 4u plus 1. So now set each factor equal to 0 and solve. Wow, u equals 3 over 2. Oh, buckets, 3 over 2. U equals negative 1/4. Well, now that I've solved for u, I have to use u substitution and plug in x to the 1/5 now for u. Okay. To get rid of a 1/5, remember I raise it to the reciprocal of 5 over 1 or to the 5th power. Now your calculator is going to struggle to do a fraction to the 5th power. It'll be a huge number or huge decimal. So it may work out. They may be able to give you the fraction, and if it has an error, it gives you some scientific notation. All right, just do the numerator and the denominator separately. So 3 to the 5th, which is 240, or no, sorry, I'm looking at the wrong. Yeah, 243, and then over 2 to the 5th, which is 32. So just do them each separately. 3 to the 5th, enter. 2 to the 5th, enter, and then just make the fraction. Okay. Same thing over here. Obviously, we know negative 1 to the 5th is going to give us negative 1, and then 4 to the 5th is a huge number. That's 1024. Yeah. 1024. This is 243. I hope it doesn't look like an exponent. Okay? And those both work out. There's our x values. Alright? We'll pick up with 18 next. Can't wait.